Hi guys, welcome back to my channel. In this video, I'll tell you how to send data between two Arduino devices using a simple communication protocol that I created myself. Usually, people use built-in functions like Serial.write or Serial.read or use the I2C protocol, but this time, I'll go a step further by utilizing the basic functions like digitalWrite and digitalRead. Later, I'll use digitalPin for data transmission. So, let's get started. Be sure to stay tuned. I need to prepare the Arduino device first. In this video, I use Arduino Uno as the sender and Arduino Nano as the receiver. This is up to you. Then what is the main process for sending the data? In this video, I didn't use functions like Serial.write or Serial.read. I just used basic functions like digitalWrite and digitalRead. Absolutely, let's break down the key process of sending 1 byte of data, which includes 8 bits, and a simple communication setup like this. We'll use the example of sending the character A, which in binary is 01000001. So when we kick off the transmission, we start with what's called the start bit. It's like a little signal that says, hey, get ready, data is coming. In our case, it might be represented as a high signal, turning the pin on. Then, let's talk about the main event, the 8 data bits. For each of these bits, we're going to send them one by one. If the bit is 1, we'll turn the pin on. And if it's 0, we'll turn it off. For our example, we do something like this. Send bit 0, turn the pin off. Send bit 1, turn the pin on. Send bit 2, turn the pin off. Send bit 3, turn the pin off, etc. Each bit gets its moment to shine, and we're representing the A character by this sequence of on or off states. Finally, after we've sent our 8 data bits, we wrap things up with what's called the stop bit. This is another little signal to say, okay, we're done here. It's typically represented by a low signal, so the pin goes back to being off. Without further ado, let's create the code. Time to peek at the sender's code. I'll walk you through it, no worries. First, I declare pin D3 as input and pin D2 as output in the setup function. Then in the loop function, I send the data. I send the data as characters bit by bit through the output pin. Each bit is sent with a delay using delay microseconds. In this loop, the character A is sent bit by bit. Each bit of the character is sent one by one via digital pin 2. This code is used to shift the bits to the right so that the bit being sent is in the rightmost position. And this code takes the last bit value of the shift. Now let's peep at the receiver's code. I'll break it down for you. In the setup function, initialize pin D2 for output and pin D3 for input. Then in the loop function, Arduino checks for incoming signals. If there is a signal, high, then Arduino will receive data. Next, Arduino receives data bit by bit through the input pin. Each bit is received with a delay using delay microseconds. In this loop, the program reads bits one by one from digital pin 3. The bits read are arranged into a byte or char, using the OR operation. This code combines the read bits into bytes that will represent the received data. After that, we wait for 3 seconds before continuing the next reading. After we make the code, we connect the pins on both Arduino devices. And we upload the code to the both of them. Ta-da! Done! The program is running fine. We can also improvise by using a push button as a trigger for sending the data. Like this. I connect the push button to pin D8. So when the button is pressed, the data will be sent. Let's check it out. It works. Yay! That's how I create a simple communication protocol between two Arduino devices. I hope this explanation helps you understand each step in the code. Feel free to leave comments if you have any questions or suggestions. See you in the next video, guys. Thank you.